Chapter 7.1, we're looking at inverse variation. So in this first exploration, we want to see the relationship of a weight and the distance of a spring. And so this is supposed to help us to understand direct variation. So notice here, first, if there's no weight, the spring isn't expanded. Then you add 0.1 kilograms, it expands, right? So this is the equilibrium. And so we're measuring the distance here. And then as you add a little bit more weight, the distance gets larger, and more weight, distance gets even larger. So what we can say is that the relationship between the weight x and the distance d is that as the weight increases, the distance of the spring also increases. So let's just call that x. As x increases, and then instead of calling the distance d, we'll call it y increases. Okay, distance is y. So let's look at this example here, inverse variation. So this is the table. It shows the length x in inches and the width y in inches of a rectangle. So if we know that the area of the rectangle is 64 square inches, so that doesn't change. Remember, in order to find the area, it's length times width, or base times height. So really, we're looking at x times y. So x times y should equal our area. And we know that the area in this case is 64 inches squared, so xy equals 64. And so if we plug in our x of 1, we just want to solve for y. So maybe let's do this. Let's isolate the y value because that's what we're trying to find. So divide by x. We're looking at y equals 64 over x. So if x is 1, so we plug in 64 divided by 1, then we know this is 64. Then we plug in x is 2, 64 divided by 2, well, that's 32. And then so maybe you see the pattern. So 64 divided by 4 is 16. And 64 divided by 8 is 8. 64 over 16 is 4. And this would be 2, and this would be 1. So notice the pattern here. As x, it's increasing, y is decreasing. So that is inverse variation. So the relationship between x and y, as x increases, y decreases. And so that's why they vary inversely, right? They are kind of like opposite. So if x decreases, so if we're going the other direction, x decreases, then y will increase. So it's going in the opposite direction there. So that's the general idea about direct and inverse variation. So two variables, x and y, show direct variation when y equals a times x for non-zero constants. So notice that if we plugged in a number here, so let's just say this is 3, we plugged in x, so if we plugged in x is 2, so 3 times 2, that's going to be 6. If we plug in, let's say 10, x is 10, what's going to happen to y? That gets larger, right? So as x increases, y increases. Now, two variables, x and y, show inverse variation when they're related as follows. So this is y equals a over x, and then a is not 0. So let's again plug in numbers. So let's just say the top number is 2. So y equals, let's say, 4. So, I'm sorry, when x equals 4. So 2 over 4 is a half. And then when we plug in, say, x is 100. So we get y equals 2 over 100. That is going to be 1 over 50. And then think about that. What is larger, 1 over 2 or 1 over 50? Well, half is bigger than 1 over 50, right? A 50th of, say, a piece of pie. So 1/2 is larger. So notice as x gets larger, then the fraction shows a smaller number, right? So 2/4 is a half, 2 over 100 is 1 over 50, and it's getting smaller and smaller. So that's inverse variation. Now we're going to tell whether x and y should direct, inverse variation, or neither. So what we're going to do is to solve for y. That's what I would hint at. Solve for y to help us out because we want it to look like the equations up at the top. We want it to look like either y equals x or y equals a over x. And if it doesn't look like that, where it's dividing or multiplying, then it's neither. So let's try this first example. X times y equals 5. Now again, solve for y. So y equals, 5 over x. So therefore, this is inverse variation. Letter B. So y is already isolated, and we have x minus 4. So that is not multiplying or dividing, so therefore in this case, it's neither. Letter C, we have y over 2 equals x. So we want to isolate the y. So let's multiply both sides by 2. So therefore we get y equals 2x. So therefore that is direct variation. So try these 3 below. So trying this out, number 1, that is direct variation. You didn't have to rewrite it because y is already isolated. Y equals 6x, and so that's multiplying, and so that is direct. Number 2, we have to divide by x to isolate our y, and we notice that that is inverse variation. Number 3, that is neither because that is subtracting. You have negative x plus 10, so that is neither.